Well, that's how Lemming started out as, right?
Oh, okay. So it'd be 9 centimeters.
So you start at 10, and then you apply 2 force, 2 times the force. So how long did it stretch with 1?
We added
Yeah, so it stretched just 1 centimeter though.
it. So yeah.
So when you compress it, how far will it compress? You use 2 force.
So 8.
Yeah. Yeah, so either direction that you go, either tension or compression, if it's obeying Hooke's law, it'll always stretch or compress by the same distance.
I can do that one. On elastic potential energy. So inelastic, it's this is just the opposite of inelastic, right?
No, so elastic and inelastic, before we were talking about like with collisions.
Right.
So now we're talking about energy. So there's a couple of different types of energy, right? Kinetic and potential. That's the right. So an object has kinetic energy when it's moving. And it has potential, like gravitational potential energy when it's like up off the ground. So if you have something that's high up above the ground, it's got potential energy, and when you drop it, it'll switch into kinetic energy. What if you take something, you push it onto a spring and compress the spring? What would happen if you release the spring?
It would go back to where it was at.
Yeah, so it'd shoot out. And
Shoot.
so that's another form of potential energy. It's elastic potential energy, either when you stretch a spring or compress a spring. So for example, like with a bow, you pull a bow back and you put energy into that string, and then it's just sitting on the arrow. As soon as you let it go, that elastic potential energy is converted into kinetic energy.
Okay.
Pushes that arrow out. And the equation for it, so U spring, so U is for potential energy. It's equal to 1/2 Ks squared. So this is kind of like kinetic energy is 1/2 mv squared. That's kind of how I remember it. You got a 1/2 and then Ks squared. K is your spring constant. That would usually be given to you. And S is the distance. Either that it was compressed or stretched. So if you had a spring that was originally just when it was just sitting there, let's say it was like 2 meters long, and then you compressed it down to 1.5 meters, and it had a K of 800 newtons per meter. How much potential? Like, how would you find the potential energy here?
Please do 1/2 times
Oh, it's this one. So
Oh,
you
what
use
happened?
K.
K, so kinetic,
This is,
so 800.
yeah, so that's just a constant, it's the spring constant.
Okay.
It's a lowercase k.
Times 1.5.
So S is how much it changed.
Oh,
So
from
that's
2
the-
to 1.5?
Yeah.
Okay, so 0.5.
That's the trick there, is you just have to watch out for how long it was originally.
Or we do negative 0.5.
Well, either way, you square it, so it doesn't matter. It'll always be positive,
Okay.
whether you compressed it or stretched it. So that'll be 0.25 times 800. So that's 200 times a half. This would be 100 joules of potential energy for that spring. And then the same thing, what if you took that spring and instead you stretched it out to like 4 meters? How would that change your equation up here?
It'd be 2, so 0.5.
Right. That's 32, 1600. It makes a pretty big difference how long you stretch it or compress it.